So the next person is from the country Sweden, and his name is Johan. He is from KTH, and his surname is Nordstrand. Give warm applause for Johan Nordstrand.
Thank you.
Thank you, man.
So, hi everyone, and thank you for coming to this presentation. So yeah, my name is Johan, and I'm from KTH Royal Institute of Technology here in Stockholm. Scarcity of fresh water is one of the great challenges of our time. And as you can see, we have an issue here, because the vast majority of the water resources on Earth contain too much salt. We cannot drink it. So desalination technologies are and will be crucial for meeting the global demands. So what we are working on is a technology called capacitive deionization. So it looks like this. And the idea is that we have two pieces of a carbon cloth, and you connect it to a power supply, a battery. So that causes an electric field, and we're pulling the ions out of the water. And that way, what comes out here is drinkable fresh water. And after a while, you fill up the cell more and more. So that means that we have to remove the power supply, and we let the ions go back. So you operate it in cycles. First you get fresh water, and then you get wastewater that we throw away. And now, the reason this technology is efficient is because of how we structure these pieces of carbon cloth. They have a very large surface area. So for every gram of this material you have, for every gram, there will be 1,000 square meters of area. So that's the nanotechnology engineering part. All right, but so to my work specifically, so I've been working with trying to develop a model that will let us describe, predict, and optimize the performance of these devices. And I will try to give you the big picture idea here. So basically, there are two properties we are interested in. So one thing is, how much salt can we remove from the water? Because at the core, that will determine how efficient our device is. But we are also interested in, when you connect the power supply, how much charge do you need to store? Because that will determine your energy consumption. So again, on the big picture idea, we are looking at the model in terms of how quickly do new ions come in and how quickly do they get kicked out. And that depends on the concentration in the water, our remaining storage capacity, and then how much you kick out depends on how much you have stored already. So consider this a teaser. If you want to know the details, then please come to my poster and you can hear all about it. But so the question is, what can you do with this kind of model? Well, for instance, I mean, even here in Sweden, we have water supplies that are poisoned. You can find copper, arsenic, in addition to normal things like sodium chloride or the calcium that makes the water hard. In capacitive deionization, you can remove all of these types of charged species. And with the model, we can actually predict and describe how much you will remove of each ion type. So if we look at this graph here, we have a water sample with both calcium and sodium, and we can determine how much you pick up depending on what the concentration is in the water. So that's just one of the many application areas. All right, but with that being said, I would like to go to the conclusions here. So capacitive deionization is a promising new technology for purifying, for desalinating water. And with the model we have developed in this project, you can describe and predict how these devices will perform. So, and if there's only one thing you remember from this presentation, it's that we really need technologies that can purify water. And I sincerely hope that this technology can contribute to that. So I would like to extend my gratitude to my supervisors and to my colleagues at the Nanomaterials department at KTH. And thank you all. Thank you so much for listening.
Tack så mycket, as we say in south of Sweden. Yeah, we do that accent. Yeah, you never know the accent on the show. Where are you from, by the way?
I'm from Stockholm, born and raised.
Born and raised. I have to ask you like this. It's many. Some people are extra happy here to be Stockholm. I love Stockholm as well. I'm half Stockholm actually. Mother from Sollentuna, but we before she went to Greece and met my father. But a question here. We have many lovely students here in the room. Inspiration that you went to KTH. How come that you went to study there? What are you studying and what was your reason behind that? Maybe that can be interesting to hear.
So I studied engineering physics for the bachelor program. But then I'm very fascinated with nanotechnology and physics because we kind of know how the world works, the world we can see and touch. But nanotechnology is really a world in itself because when you zoom down to a really small scale, you get all of these quantum phenomenon and special cool things. So it's really an open area to explore.
Amazing. Can you recommend people here to go to KTH for those who are striving or want to go there?
Definitely. It's a very good school.
Amazing. Then we can only end with saying that we recommend you to stay in Sweden because we need you, sir. Okay, so give him a warm applause and thanks to Johan Nordstrand. Thank you. I can keep this one here, yeah.